Hi everyone, today I'll be looking at a few revision questions for trigonometry. First, I'm going to start off with converting from degrees
to radians.
So if I have, for example, 300 degrees and I need to convert this to radians, I will have to multiply this by pi over 180. So I'm going to multiply it by pi over 180. So 300 degrees times pi over 180. And then we go ahead and we simplify. Now I can cancel one of the zeros. And then you have to think about the numbers that can go into 30 and 18 without leaving a remainder. Now for 30 and 80, we can use 6 because 6 goes into 35 times and 6 into 18 goes 3 times. So what am I having? It is 5 times pi, that's 5 pi over 3. So 300 degrees is the same thing as 5 pi over 3. If we have 75 degrees that we need to change to radians, then we times it by pi over 180. And in this case, we have to reduce again. Now you have to think about the numbers that can go into both without leaving a remainder. Let's start with 3. 3 into 75 goes 25 times. And then we know that 180, I can divide it by 3, and that gives me 60. But we can continue further because 60 can be divided by 5. So 5 into 60 goes 12 times, and 5 into 25 goes 5 times. So that means my answer is 5 times pi, that's 5 pi, and over 12 because we have a 12 in the denominator. So 75 is the same thing as 5 pi over 12. Now we can move in the reverse where we change radians to degrees. So if I have, for example, pi over 3, and don't forget your radian sign here. So pi over 3, convert to degrees, I will times it by 180 over pi. So the pi's will cancel, and then 3 can go into 180. So 3 into 180, we have 60. So that means the answer is 60 degrees. Another example, we can have 13 pi over 5. We need to convert this into degrees, so I multiply it by 180 over pi. Once again, the pi's will cancel, and now 5 can go into 180. So once you can reduce, you reduce. So 5 into 180 goes 36 times. We have a 13 here, so we multiply 36 times 13, and that will give us 468. So in this case, our answer is 468 degrees. So 13 pi over 5 is the same thing as 468 degrees. Now let's look at some proof. There will be time where we ask us to prove that left is the same as the right. So for example, I can ask you to prove that 1 over tan x plus tan x is the same thing as 1 over sine x cos x. Now, the identity for tan x, so this is where its identity comes into play. So the identity for tan x is sine x over cos x. So sine x over cos x. So where I have tan x, I would have it as 1 over sine x over cos x And this tan x, I'll have sin x over cos x. If you realize I use the left-hand side, most times it's the left-hand side I use because it has a lot of information and it's easier to work in that route. So once you have a fraction in the denominator, we reciprocate it or flip it. Just remember, if I have 1 over 3 over 5, it's the same thing as saying 5 over 3. So that's the concept I'm going to use here. So this is the same thing as cos x over sin x. And then I have plus sin x over cos x. Now, LCM, we know how to do LCM. If I have a half plus 1/3, you see the LCM is 6, where I can say 2 times 3 is 6. So it's the same concept here. Just like how we say 2 times 3 is 6, I'm going to say sin x times cos x, that's sin x cos x. So that is my LCM. Now, after we say 2, 3, 6, we'd say 2 into 6 goes 3 times, and then multiply this by 3. So 3 times 1, that gives you 3, plus 3 into 6 goes 2 times, so 2 times 1, I will get 2. Same concept here. Sin x into the denominator, this sin x will cancel, so I'm left with cos x. So we're going to multiply cos x times cos x here. And when you multiply the same trig function, you get the square of x. So this becomes cos square x. Plus sin x, well, cos x into the denominator, this cancels. So I'm left with sin x. I multiply the numerator by sin x. So sin x times sin x gives you sin square x. Now, there is an identity that says cos square x plus sin square x is 1. So that means the addition of this is 1 over sin x cos x. And as you can see, we have the above, so therefore proven. Now, the next one I have here is sin x minus sin x cos square x equals sin cube x. So I need to prove that the left is the same as the right. I like to work with the left hand side. Now, looking at this, sin x is common. For example, let's look at algebra when we have 2 minus 2x. The 2 is common, so I'd factor out the 2. And then when I factor out 2, you leave 1 as a placeholder here. This 2 is being removed, so you have minus x. So same concept, factor out sin x. When I factor out sin x, I'm left with 1 minus cos square x. Now this is an identity. So the identity that is I can use is sin square x plus cos square x is equal to 1. So if I carry this over, then I have sin square x is equal to 1 minus cos square x. So in other words, this identity, 1 minus cos square x, is the same thing as just saying sin square x. Therefore, I'll have sin x times this, which is sin square x. And then finally, just like how I can say x times x squared would give me x cubed, it's the same concept here, where sin x times sin square x is sin cube x. And as you can see, we have proven that the left is the same as the right. Now I have another one that I'm going to look at. So if I have cos x over 1 minus sin x minus cos x over 1 plus sin x is equal to 2 tan x. So as I stated, I love to work on the left-hand side because that's where I have the most information to work with. So having this, I will go ahead and find the LCM. So the LCM of 1 minus sin x and 1 plus sin x, I'm just going to rewrite it. 1 minus sin x and 1 plus sin x. Now 1 minus sin x in the denominator, this is going to cancel, so I'm left with 1 plus sin x. So I have cos x times 1 plus sin x minus 1 plus sin x into all of this. This cancels, so I'm left with cos x times, remember 1 plus sin x into the denominator. This cancels, so I'm left with 1 minus sin x. So I have my 1 minus sin x. Now cos x times 1, that gives you cos x. Cos x times sin x, that gives you plus cos x sin x minus cos x times 1, that's minus cos x. And then we have minus cos x times minus sin x, that's plus cos x sin x. Go ahead, rewrite the denominator. However, looking at the denominator, we can see something. It's behaving like if I have difference of 2 squares. So if I have 1 minus x times 1 plus x, difference of 2 square is the same thing as 1 minus x squared. So it's the same scenario here. This is the same thing as 1 minus sine square x, difference of 2 squared. But you could expand it or say 1 times 1 is 1. 1 times sine x is positive sine x. But it's going to cancel with this minus sine x, because minus sine x times 1, that's minus sine x. And minus sine x times positive sine x give me minus sine square x. Now the cos x in the numerator cancels. Cos x sin x plus cos x sin x gives us 2 cos x sin x over 1 minus sine square identity is the same thing as cos square x. So this is cos square x, but cos square x is the same thing as saying cos x times cos x. So in the numerator, I have 2 cos x sin x over cos x times cos x. So the cos x cancels, so I'm left with just 2 sin x over cos x. But we know the identity that this represents tan. So you see that we get the 2 tan x. And therefore, we have proven. We can find the exact value of a cos of an angle using the compound angles formula. So for example, if I have cos 105 and I want to find the answer without the use of a calculator, I can think of 2 angles that when I add or subtract, I'll get 105. The 2 angles that I can use is 60 plus 45, because 60 plus 45 will give me 105. Now, the compound angle formula is that when you add, you will have the formula cos A cos B minus sine A sine B. Now, for questions like this, usually they say, okay, show that it's equal to, say, for example, 1 minus root 3 over 2 root 2. So I'm working towards getting this. So A in this case is 60 and B is 45. So substituting, I have cos 60 times cos 45 minus sine 60 sine 45. Now cos 60 is a half, while cos 45 is 1 over root 2, or some persons will say root 2 over 2 is the same thing. Sine 60 is root 3 over 2 times sine 45 is 1 over root 2. Now, simplifying, 1 times 1 is 1, and 2 times root 2, that's 2 root 2. And then we have root 3 times 1, that's root 3. And then 2 times root 2, that's 2 root 2. Now, because we have the same denominator, we write it once, so I have 2 root 2. And then we subtract the numerator, so I say 1 minus root 3. And we leave it as it is. And that's it. We get the following. Now, the next one we could have gotten, say, for example, tan 15. And we need to show that it's the same thing as root 3 minus 1 over 1 plus root 3. Now, first you think of how can I rewrite tan 15 with two angles. Either we add or subtract to get 15, and I can use tan 45 minus 30. So use two numbers that when you add or subtract, you will get the number that I have here, which is 15. Now the rule is that when we subtract tan, we'll have tan A minus tan B over 1 plus tan A tan B. So in this case, A is 45, B is 30. So substituting, I have tan 45 minus tan 30 over 1 plus tan 45 times tan 30. Now, tan 45 is 1, and tan 30 is 1 over root 3. While in the denominator, we have tan 45 is 1, and then tan 30 is 1 over root 3. Which means that we have 1 minus root 3, 1 over root 3. So 1 minus 1 over root 3 in the numerator, all over 1 times 1 over root 3, that's 1 over root 3. So I have 1 plus 1 over root 3. Now we need to simplify. So the numerator, I have 1 minus 1 over root 3. I can find the LCM. So the LCM is root 3. And I could put this as 1 over 1. So 1 into root 3 gives us root 3. So root 3 times 1, that's root 3. Minus root 3 into itself goes 1 time. So 1 times 1 is 1. So that's the numerator. The denominator, I have 1 plus 1 over root 3. And you should be seeing the pattern. So this is 1 over 1. So the LCM is root 3. Then 1 into root 3 is root 3. And root 3 times 1 is root 3. plus root 3 into itself goes 1 time. So 1 times 1 is 1. So the numerator, I will have root 3 minus 1 over root 3. But the denominator, this means divide. So I'm going to put divide. Then the denominator simplify to give me root 3 plus 1 over root 3. Now division is the same thing as multiplication. So I have root 3 minus 1 over root 3. And then we reciprocate this. So this becomes root 3 over root 3 minus 1. Sorry, root 3 plus 1. So these cancel. And as you can see, I've gotten the result, which is root 3 minus 1 over the root 3 plus 1. That's it.
Don't forget to like and subscribe to my channel. Have a great day.